Lesson 10.4, Common Logarithms for Algebra 2 Honors. So what are the two most common logarithms we use? What are they called? Well, the first one's called common logarithm, although I never call it that. It's a log base 10, and I'll write an equation just for the fun of it. 100 equals 2, meaning 10 squared equals 100. That's called a base 10 or a common logarithm. The other is called a natural logarithm, and we will actually work with that next. And it's log base e, which is never written that way. It's written natural log. And it's assumed, if you see ln, which is French for log de la naturelle or something like that, that means immediately that you are saying, oh, it's a log base e. So I could just put in e to the third equals 3, and this would mean e to the third equals e to the third, which is pretty stupid. That's a natural logarithm. We will cover that next unit. Common logarithm is base 10, and it's actually written without the 10. Like that. And the point of that is, oh, there's nothing there, just like the natural logarithm. Let's just assume it's a 10. It's on your calculator, both of them. Down here on the left side, it says log, and you know it's base 10 because right above it is a 10 to the x. And like I just said, 100 should give me 2. And second, not second, well, second, right above it, 10. Second, 10 squared equals 100. So that's forwards and backwards. Natural log, and e is directly beneath it. I said e to the third. Equals 3. And then second e to the third equals whatever, 2.78 multiplied up. What's 2.78? Coming soon. We'll get back to it. So anyway, how do we use them to solve exponential equations? Just going to do it with common logs, but you can, and I'll show it once right here how you could use either one. But we know that if we take the log of both sides, we can take this x and throw it out. And this is one of the most important reasons that we actually need logarithms, so we can get that number out of the exponent. So x equals log 11 over log 3. What do we get? Log 11, close parentheses, divided by log 3, 2.1827. Now here's something that'll freak you out a little bit. I told you earlier I could use log base 10 or natural log. So if I do natural log of 11 and I divide it by natural log of 3, different base, get the same answer. Pretty cool. So that's really all the hard stuff today. The hard part, pardon me, that's all the basic stuff. The hard part is going to be doing this with a inequality. We're going to have to number line it and figure out what's going on. This is y minus 1 log of 8. And got to distribute. I'll leave log in the answer for now. Y times 3 log of 5 minus, I'm going to pull the log over. It's log of 8y. Y log of 8 less than negative log of 8. Factor out the y. And by the way, you could do this by putting in decimals. I don't want to just because I'll be bouncing back and forth with my calculator. And that's annoying. And then divide out. So y has to be less than, and I'm using a calculator off on the side, parentheses on the top, parentheses on the bottom. I get y has to be less than negative 0.7565. Notice all the decimals and what a hassle it is to keep that straight. So I check it by throwing in a number here. Less than that would be negative 1. Five to the negative 3, less than 8 to the negative 2. Is 0.008 less than 0.0156. Yes, works. I should probably put this back in and check. I'll actually do that on the calculator. 3 to the 2.1827. 3 to the, oh look, it's sitting right there. I'll just say answer. Should give me almost exact 11. It does. So you can check your work, which is nice. Now this is a change of base formula, which I always laugh at because people want a formula. But what we're saying is that your calculator is log base 10 and natural log sitting there. So how do we use those to solve something with a different log? I believe it's going to be log base 12, and it's missing, so it's a 10, over log base 5. Let's prove it. If we were to solve this, I'd say make it equal to x, and then rewrite it with BOI, 5 to the x equals 12. And then I would take log of both sides, log of 5, log base 10, but again, I don't write it, equals log base 12. Bring the x out front. X log of 5 equals log of 12. Divide both sides by log of 5. And there it is. X equals log of 12, log of 5. As I noted earlier, you could also have done all this with a natural log. But look, I got it. So how do I keep it straight? How do you remember it? I just say it's log of the top divided by log of the bottom. And for whatever reason, that has stayed in my brain, and I can do it. So when we have a calculator, I need to know log base 5 of 12. Well, that's just log of 12 divided by log of 5. Or, hey, I felt like using natural log of 12 divided by natural log of 5. I think I hit the wrong button there. Same answer. That's it. Change your base formula. Good luck.